Standard 12 exercise 8.11 UV light of wavelength 1800 Armstrong is incident on a lithium surface whose threshold wavelength is 4965 Armstrong. Determine the maximum energy of the electron emitted. Okay. So here the wavelength is given as 1800 Armstrong and threshold wavelength is given as 4965 Armstrong. We have to find out the maximum energy. So we have to find it out, kinetic energy maximum. Okay. Now we know the formula h nu is equal to phi 0 plus kinetic energy maximum. So you want to find out kinetic energy maximum. So that is equal to h nu minus h nu 0 because phi is equal to h nu 0. Okay. But here the frequency is not given, the wavelength is given. So it is hc by lambda minus hc by lambda 0. So this can be written as hc into 1 by lambda minus 1 by lambda 0. So this can be written as hc into lambda 0 minus lambda by lambda 0. So which can be written as h value hc into 4.965 minus 1.8, okay, into 10 raised to minus 7 by 1.8 into 4.965 into 10 raised to minus 40. Okay. Now here it is, hc value is 6.626 into 10 raised to minus 34 into 3 into 10 raised to 8. If you subtract this, you will be getting it as 3.165 into 10 raised to minus 7 divided by, here it is, if you multiply these two, you will be getting it as 8.96 into 10 raised to minus 40. Okay. So if you multiply this is these two, if you multiply 19.878 into 3.165, okay, into 10 raised to minus 19 divided by 8.96. Okay. Now this, if you want to convert it into electron volt, we will be getting it as this is 62.913 into 10 raised to minus 19 divided by 8.96. So this is 7.021 into 10 raised to minus 19 joules. So if you want to convert it into electron volt, this is 1.6 into 10 raised to minus 19, divide it. Okay. So if you divide it, you will be getting it as 4.40 electron volt. You will be getting this value as what? 4.40 electron volt. That is your kinetic energy maximum.